So today's lesson on energy classifications is actually fairly quick. It's really just making sure we're comfortable with some of the vocabulary that's going to be common within this energy unit, rather just at the beginning of this unit, making sure we understand some of the vocab that comes up with energy a lot in this chemistry class. So with that being said, what the heck is energy? Energy specifically refers to the ability to do work or transfer heat. So with that being said, we want to make sure we know what work and heat are. Work is defined as energy transferred when a force acts over a distance, meaning that anytime I move something like my cell phone across the table, my calculator across the table, I'm putting work into those substances, into those things in order to get them to move. Heat specifically is referring to the transfer of energy between hot and cold substances. And what does it mean to be hot or cold? And that kind of comes up a little bit with temperature. Now, if I were to ask you to define temperature, and if you were to turn around and say it's the measure of how hot or cold something is, that would not necessarily be the best way. Temperature specifically is the measure of the average kinetic energy of particles within a system. Particles that are hotter move faster. They have a higher average kinetic energy. Particles that are colder move slower. And therefore, when we're looking at heat, looking at that transfer of energy, the particles that are hot, they're moving around really fast, they come colliding into each other, and they'll transfer their kinetic energy from the hot particle to the cold one, causing the cold particle to move faster and the hot one to move a little bit slower. That's represented a little bit with this image down below here. The cold particles are over on the left-hand side. They're indicated with the shorter trailing lines behind them. They're moving slower. They have less vibrational or kinetic energy. The ones on the right, on the other hand, the particles are moving significantly faster, and that's represented with the longer trail lines. So generally speaking, particles that move faster have a higher energy. We could also look at the mass of the particles as well, but we'll get into that in more detail a little bit later on down the road. So with that being said, we want to make sure we can define kinetic energy. Kinetic energy is the energy due to the motion of particles. Now, if you're in a physics class, you've probably seen this formula here. Kinetic energy is defined as 1/2 the mass times the velocity squared. And you can definitely determine the kinetic energy of a single particle if you know how fast that particle is moving and how heavy that particle is. But at the end of the day, that's kind of pointless in the world of chemistry because if I have a sample of particles, I have an uncountable number of particles. And generally speaking, they're moving so fast and they come into collision so often that if you were to manage to determine the kinetic energy of that single particle, it's almost definitely going to change a few seconds later. If two substances have the same kinetic energy, then their velocity is dependent on their mass. The heavier particles tend to move slower. Lighter particles tend to move faster, especially if they're at the same temperature. Last but not least, I want to make sure we understand a little bit about potential energy. As we are all aware, potential energy is the energy due to the position or makeup of the particles. Now, in our world of chemistry, the lower the potential energy, the more stable the system tends to be. In chemistry, we're also going to be looking at how energy can be stored in bonds, and this is usually due to electrostatic potential energy. This results from the attractive force between opposite charges or the repulsive force between like charges. Now, obviously, if we're forming chemical bonds, we're looking more at the attractive force between particles rather than the repulsive force. With that being said, it's kind of like a balancing act. There are particles within the atom that attract other particles in the atom. There are particles in the atom that repel other atoms in the other particles in the atom. So it's really kind of a balancing act. And once again, the whole goal of a lot of these atoms and chemicals is to lower their potential energy state, making them inherently more stable. Once again, that was just an overview and some of the vocabulary that's going to be coming up in terms of energy. Don't forget, you have a graphic organizer that follows along nicely with those lessons. Thank you so much.